All right, now we're going to look at compound interest, and I'm going to give you a couple formulas, okay? There's two different types of compound interest we're going to look at. Number one is called periodic compounding, okay? Where I have A is equal to P times 1 plus R over N time to the nt power. That looks really terrifying. It's not actually too bad. So again, A is my future value of my investment or loan. P is my present value. So that's what I invest now or what I owe now. So that's the principal, some people call it, but present value is another way to look at it. And of course, R up here is my interest rate, my compound interest rate. Okay, so far we got these three, right? Okay, and then N is the number of times compounded per year. So sometimes we compound things once a year, so it's compounded annually. That means that N would be 1. Okay, so a little side note here that for this one, if it's compounded annually, then N would be 1. If it's compounded quarterly, I'm just giving you some examples, then N would be 4. That means that it's compounded 4 times a year. If it's compounded monthly, then N would be 12. It's compounded 12 times a year, and so on and so forth. If it's compounded semi-annually, that would mean that it's compounded twice a year. N would be 2. You get the idea. And then, of course, T again is time in years. Okay, so that's what all the letters mean in this, okay? So future value, present value, number of times compounded per year, interest rate, and time in years. So that's called periodic compounding. Okay, then we have something called continuous compounding. Okay, so periodic compounding is when it's compounded so many times a year. Continuous is what it's you'll actually see in the directions. It'll use the word continuous instead of something like quarterly or semi-annually or monthly. So continuous compounding is A equals P times E to the RT. Okay, E is the natural number. Okay, E is the number like pi. If you look on your calculator, I'm going to show you kind of how to do this on your calculator a little bit later, but again, A means the same thing it did above. All right, A is the future value. Okay, P is the present value, R is the interest rate, and T is the time. So all the letters mean the same thing except for E is this special number, and we're going to mess with that later when we actually get to a problem. Okay, so this tells me how to look at continuous compounding. All right, so let's look at some examples using these formulas. Okay, I wanted to briefly show you in the calculator where the E button is and all that for that continuous compounding thing. So I took a photo of my calculator. PE to the RT. Remember that one I just put up? That's the continuous compounding. So when you get to the point that you need to use the E, you see on your calculator that there's right above the LN button here. I'm going to get a different color here. If I look in orange, right above the LN button is an E to the X button. Do you guys see that? That's how you would enter something. So if I needed to do something like A equals, like $15 times E to the, I don't know, let's say RT was 0.85. You just plug into your calculator 15, hit the times button, then you'd hit the second button, and then you'd hit the ln or the e to the x button that I just circled, and then you'd put in, I'm out of room there, I'm going to scroll, then you'd plug in 0.85 into your calculator, and then you'd hit enter, and that would give you the value. Okay, so that's just a quick tutorial on how to use the e to the x button for these continuous compounding things. So let's now go to an example problem. Okay, so find the accumulated value of an investment of $5,000 for 10 years, interest rate is 6.5 semi-annually, quarterly, monthly, and continuously. Okay, so for our general formula are going to be our general two formulas, which I'll do in blue, will be P times 1 plus R over N to the NT. Okay. And our continuous compounding one will be PE to the RT, the PERT equation, we call it, PERT. So these are our two equations we're going to use. For letter A, we're going to get A. So how much are we investing here right now? The present value, the amount we're investing now, is $5,000 times 1 plus R over N. R is 0.065 over N. Well, if I'm compounded semi-annual, that means twice a year, right? So I'll put a 2 in there. And then that'd be 2, which is N, times the time, which is 10 years. Okay, I can actually plug this into my calculator, believe it or not, just like that. The way I'd plug it in, I'm going to write this here, is I'd actually do 5,000 times, and you could put a parenthesis in your calculator, and you can actually put in 1 plus 0.065 divided by 2, and then hit the little up caret for the exponent, and then, depending on which calculator you have, some of you will have to do a 2 times 10 in there. Some of you have a calculator that will automatically like push it up into the exponent, so you don't actually need the parentheses, but you can actually plug that right into your calculator, and let's see what I get. And it looks like for that I get 9479.19 rounded to the nearest cent. Okay, let's try it quarterly. Well, to do it quarterly, all I got to do is change that to 4 times a year. Change the N to 4, so I change it, notice I change it both here and here, you see an N. And that gets me, if I just hit second entry on my calculator, I can actually just go ahead and edit that. You can actually just go up and edit the last entry and change the 4 in both places. Change the 4 in both places, and I get 9527.79 for that one. And then if I wanted to do monthly, I'm not actually going to do the monthly one. I would just literally go through and change that to a 12. But let's do the continuously one. If I want to erase this, I can do the continuously part D. And that would be A is equal to P, which is $5,000, times E, and in the exponent would be 0.065 times 10. Okay, so I do 5,000 times, hit the second E to the X button, the one I showed you a minute ago. I do 0.065 times 10, and I get 95.77. And continuous compounding should always get you more money than the other ones. So actually it should be that for A, B, C, and D, the amount that you're going to have from the investment gets larger and larger each time because you're compounding it more often. And when you're compounding more often, so the idea of compound interest, different than simple interest, is that when I put the money into the bank account and it compounds, and I get some money back, then when they refigure for the next period what I'm going to earn, they use the new amount that I have in there. So it just keeps like the present value keeps growing every period. So that's why compound interest is much better than simple interest. But it's also a lot worse than simple interest when we're using a loan, because that means we're going to owe more faster as well. Okay, let's try another example. How much money should be deposited into an account that earns 10.5 compounded monthly so that it will accumulate $22,000 in 4 years? Well, this is compounded monthly, so I'm going to use the periodic compound. It's not continuously. Okay. So what they give us is they give us something here. So they give us A. They know that we want to have $22,000 in 4 years. So that means my future value is going to be 22 grand. That's what I want to have in 4 years. Okay. I want to know how much is deposited today. That's my present value. I don't know that. That's my unknown. So today would mean present value. So we're trying to find the present value in this problem. I know my interest rate over here is 0.105, changing that to decimal. I know my N is compounded monthly, so that's 12. And I know my time is 4 years, it says right here. If you look at 4 years. So I've got all the variables except for the P, so this problem shouldn't be terrible. So let's put them in. So this is 22 grand is equal to P, which I am trying to find, my present value. What do I have to invest now in order to get the 22,000 later? That'd be 1 plus 0.105 over 12. And then my N is 12 times 4, which is my time. So let's just simplify this a little bit. Let's do the part inside here first, just for a minute. You'll see what I'm going to do here. So 1 plus 0.105 divided by 12. Okay, this is, I keep not changing back to my color. P times, this is 1.00875, and 12 times 4 is to the 48th power. Excuse me. So I want to divide both sides by 1.00875 to the 48th power. And then these cancel. So now I just need to do 22,000 divided by 1.00875 with the exponent to the 48th power. And I get that P equals 14,481 and 46 cents. So if I want to have $22,000 in 4 years deposited into an account at 5% compounded monthly, that's what I'd have to invest in order to have $22,000. Okay, so what you're doing here, guys, is you're playing around with knowns and unknowns and then using your algebra ability to solve for the variables you need. So they gave us the future value. We had to find, sorry, I'm going to underline that. They gave us the future value, and we had to find the present value, what we'd invest today in order to get that. So that's a problem you're going to encounter. Let's do another one. You deposit $6,000 in an account that pays 5.25% interest compounded semi-annually. After 10 years, the interest rate is increased to 5.4% compounded quarterly. What will be the value of the account after 18 years? Okay, so this is kind of two problems. For the first 10 years, okay, and then we have the next 8 years, right? Because it's a total of 18 years. So for the first 10 years, we're at 5.25% compounded semi-annually. So my N is 2. Do you guys see that? For the next 8 years, we're at 5.4% and we're compounded quarterly, so my n equals 4. What will be the value of the account after 18 years? So let's deal with part 1 first. We'll call this part 1 and part 2 of the investment. Let's deal with part 1 first. So my A is going to be on this side. The principal which I had, which is $6,000, times 1 plus 0.0525 over 2, because that's my n. And then that'd be n times the time, which is 10 years for this part of it. So let's find what that is in my calculator. Just quick punch that in. 6,000 times 1 plus 0.0525 divided by 2 raised to the 20th. 10074 and 29 cents is what I'm going to have. Okay? So that's the new value of the account after 10 years. So now what I'm going to do is, since this is the new value, I'm going to go over here and do the second half of the investment at the different value. Okay? But since this is the amount I now have in my bank account right here, right? This is the amount I have in the bank account. I'm going to plug that in as the new principal for this next 8-year period. Okay? Because this is how much I now have made in the first 10 years. So that has to become the new amount I'm investing, because that's what's in the bank account right now. So my new amount is going to be that, 10,074, and I'm going to leave the change off because it's not going to be significant. Usually they have you round to the nearest dollar. And then I have a new thing here. It's 0.054% at this point now. It's compounded quarterly. Okay. And so if it's compounded quarterly, then that'd be 4 for the n. And then this is now for 8 more years. That's why I put the 8 there. So let's take that times 1 plus 0.054 divided by 4 and put this in my calculator, raised to the 32 power, 4 times 8. And I get $15,473 and 0 cents actually, if you plug it in. So that's how you do like a 2-part problem, is you got to figure out part 1, find out how much part 1 is going to give you in your bank account, then you're going to use that new starting amount for the second period with the new interest rate and the new compounding frequency. So that's how we would solve a problem like that. Okay, we have one more problem. I'm trying to hit these are all problems from your book. I'm trying to hit problems like ones you're going to encounter in your homework. Okay, this one is a comparison problem. Which one's going to be better for you? Will you earn more interest in 1 year by depositing $1,000 in a simple interest account that pays 7%, or in an account that pays 6.9% interest to compounded daily? Okay, so let's do that. Let's first go with the simple interest part. Whoops. The simple interest. And then in blue, we will do the compound interest. Okay, so let's look at the simple interest. So we know that simple interest equals PRT for a year, right? We want to find which one you're going to gain more interest in. Okay. So actually, let's not do that. So my bad. Let's look at the equation. A is equal P times 1 plus RT. So let's see how much we're going to have in the account after 1 year in the simple interest account. So that'd be $1,000 times 1 plus 0.07, which is the interest rate. And we're doing this times 1 year because we're checking it in 1 year. So that'd be $1,000 times 1.07. You're going to have $1,070 in the account if you go the simple interest model. So the interest you're going to make is $70, right? Let's look at the compound interest model. One plus R over N to the NT. Okay, that is going to be $1,000 for the principal, 1 plus my interest rate is 6.9, 0.069. Compounded daily. Well, in the book, by the way, they use 360 days a year. I'm not sure why instead of 365. So we're going to use 360. It's compounded daily. And it's compounded 360 times a year times the time, which is 1 year. So let's do that. 1,000 times, I'll do this with my calculator, 1 plus 0.069 divided by 360 raised to the 360, and you end up with $1,071.43. So which one makes you more money? Well, by a small margin, this does. How much more interest will you earn? Well, obviously, you're going to earn $1.43 extra. You guys see that? Because you make, you just, $1,071.43 is $1.43 extra. So that is how you would do that type of problem. This gets you ready for that section on compound interest. We will see you guys at the Zoom meeting later.